FT8 gas fuel hose issue. This video discusses the potential issue with gas fuel flexible hoses. The early FT8 turbines came with rigid stainless steel tubing, but for some reason around 2012 Pratt & Whitney moved to a flexible hose to connect the fuel injector to the gas manifold. The rigid stainless type do take some additional time to install but work very well. The new style work well in gas-only service, but in a dual fuel configuration running on liquid fuel, there can be issues. The hose has a bellows type inner metal tube that is reinforced by a stainless steel braided exterior. Without the stainless braid the hose is weak and will fail. On numerous occasions the failure occurred at the end fitting, as can be seen on these photos. Here we see the gas fuel system, including the interface to the liquid purge. When running on gas fuel there isn't any issue, because the gas flow keeps the hoses cool. You can put your hand on the hoses, they are that cool. When running on liquid fuel, the gas hoses heat up a little due to the proximity to the metal surface of the diffuser casing. The hoses are well capable of handling these temperatures. The problem arises when running on liquid fuel. Gases from the combustion cans enter the injector gas path, and backflows towards the solenoid SOV1402. Note that the injector has two separate passages for fuel, one for gas and the other for liquid fuel. When liquid fuel is in service the gas passage can backflow. This backflow will happen if the check valve CV1101 is not seating correctly, which is common. This solenoid valve SOV1402 is open when running liquid fuel. This open solenoid valve allows the flow of gas, heating up the flexible hose, causing them to fail. This photo shows just how hot the injector and hose gets with the backflow of gases. Most sites prevent personnel from entering the enclosure when running, so you never see what is going on inside the enclosure. You can identify if this is happening, as the color of the hose stainless steel braid will change to a brownish color, similar to the change in color on the cold buffer air supply hose, which carries 13th stage air. When there is a backflow, TE1103 is supposed to increase, and alarm to indicate the problem. There is a tunable to adjust the alarm value between 250 and 300 degrees Fahrenheit. On one occasion that I investigated, the temperature only increased to 175 degrees Fahrenheit when the check valve did not seal and allowed the backflow. So you can't depend on the alarm. These are photos of the check valve CV1101. The backflow can cause contamination in the liquid fuel ending up on check valves, fuel pipes and injectors. Service Bulletin 14M02. Pratt & Whitney have changed to a different check valve manufacturer. The replacement check valve is not as prone to leakage as the older blue type shown in this photo. In summary, you should monitor the color of the metal braid of the hoses, especially close to the injector fitting, and consider lowering the alarm value of TE1103 to its lowest tunable value.